Good day, students.
Yes.
I came up with the student set and teacher set. So I'm here to use it to teach you topics on verification of theorems. There are 13 different theorems you can verify with this material. We want to take it one after the other. And when we do that, by the end of the exercise, you will appreciate that mathematics is an interesting subject. That why some people run away is that the materials required in the teaching of mathematics are not utilized. It now makes people to learn in abstract. If something is taught in abstract, the person will tend to forget. For instance, the way I'm talking to you now, if you see me anywhere, you recognize me. But assuming you saw my picture, or somebody told you about me, you may see me, you will not recognize me. That is why contact is good. That is practical, the practical aspect of whatever we are doing. In mathematics the practicals in mathematics are being suppressed, and it's not good. Apply it here. If your own is wrong, then you are wrong. You go back to your reading. If your own is correct, at least with a little difference, then you know you made a very good reading. So who will take Pythagoras theorem for us? Using this. In a right angle triangle. Yes.
Pythagoras theorem states that in a right angle triangle, NSK.
NSK, very good.
That NK squared.
NK
squared is equal to the sum of SK squared plus NS squared.
SK squared plus NS squared. Okay. Pythagoras theorem. You have stated Pythagoras theorem and you have gotten your readings. Apply it and let us see. Five 5.7. Since you don't have to worry yourself, I know you can do it. That's why I'm always jumping from table to table. You know whether you can do this one squared, which is NK squared. I know.
On the left hand side, which is NK, I got 5.8.
5.8. Is it squared or just 5.8?
5.8 squared.
Your right hand side.
2.9 squared plus 5 squared.
You have not solved it yet. Solve 2.9 squared plus. In fact, solve this. What is the square of this? That's what I want.
Okay,
Then
3.6.
That's fine. 3 points. What of here?
The two added together.
The two added together. You are still doing it. Later, I will leave the chance for you.
3.41.
That's 3.41. Yes, what's your one?
On my left hand side, I got 32.49.
32.49. And here? 33.41. We are going to look for the difference. D. The difference will tell us who is nearest to the answer. This one is 0 point. This one is 0 point what? 0 point. This one. And 2. What of this? Okay. Now, the essence of trying to do all these things practically is not to mark answer. We are not using this material to mark answers for you. We are trying to know whether you applied the procedure. 104.21. Any other solution? 102 point what? 44. So I'm going to add theorem now. Three triangles and three triangles are equal. Yes?
We have two sides.
Two sides equal. And what other property? Yes? Very good. What other? Okay. Yes? Okay. The two triangles are equal. Any other one? Very good. That's one line of symmetry. Now, if we put this at 20, we put this ruler at 20 degrees. If we put this at 20, in other words, here is 20, here is 90, here is how many degrees? So this is an isosceles triangle with here 40 degrees, 70, 70. Then this is line of symmetry. So the theorem that base angles of isosceles triangles are equal. You can now you can check 40 degrees, check 40 degrees.
Reading from ruler. Take reading, go down and know where this one, where it means. You take reading for this, take reading for this. Then you go down, whatever you see here, go down. This will give you 9 point something. Then this one, go down, take reading, go up, wherever it meets this one, this two in this intersection. Then if you want to know distance from here to here, you subtract whatever you have here. Then you know the distance here. So whatever you have here, subtract whatever you have here. Or you zero here and start counting. But you may make a mistake here because of counting. Instead, take reading here, subtract.
Just this line. This ruler where it meet this line is here somewhere. Is it not? Yes. Then go down to know the value of this line here that they meet. What's the value? You write it down. You know, have you done range? Yeah. Upper and lower range? Yes. I think that's lower range. Lower one. Lower range. Then this one, where they meet here, you take it as upper. Upper. After upper minus lower range, will give you this distance. But what concerns us now? If this and this are equal, if this, once you put this at 40, put this at 40, you check this intersection, this one, check this intersection, this one. If they are equal, then it is an isosceles triangle because two sides are equal in an isosceles triangle. And the base angles, like if there is 40, 40, 40. In other words, here is 80 degrees. Here, if this is 40, this is 90. Here is what? 50. If this is 90, 40, 90. Here is 50 degrees. So 80, 50, 50. It's 180. It's 180. And you are seeing it practically now, that this side is equal to this side. And that is, then this is line of symmetry, one line of symmetry of an isosceles triangle. To prove, show that you have to use some axioms, some known facts, and show that that one. It's different from verify. To verify that they say that the HOD mass of everything is inside this classroom. A child will come and feed. He's there. He has to verify that he's there.
And if you want to prove that he's here,
You either show that you have seen him in school today and you see him walking towards this class.
Yes. So I want you to understand the difference between prove that this is that and verify. Verify is that it is known truth. You want to go and know whether it is true. Is it true that there was an accident somewhere? People are rushing. Why? You have verified. You need to verify. So we are only trying to agree with what people are saying in the textbook. Do you understand me? We are trying to agree with them that if two angles of a triangle are equal, then the sides opposite to those angles are equal. There are some mathematical write-off here. This triangle. This one is 30 degrees, this one is 30, but you can do your own at any angle. At any way you put it. You may not put it at my own, put it at anywhere you put it. Just then determine this angle and this, then determine this angle and this. Add them to give you 180 degrees. That is verifying that some of angles in the triangle is 180. Then my own, for convenience, I put this at 30. This is 90. This is 60. This is 30. This is 90. This is 60. So this is 60, 60, 60. And this is 180 degrees. So you can put, I want someone to do it without using tractor and just change it. Whether it is still a triangle. And you can see really the angles. Just put it wherever you like, then read the values. But if they are not, you go back and check your reading. Or you call me, let me come and do it with you. But the other further explanations in writing. But what we try to achieve in this one is to set up any triangle, no matter the triangle. You determine the values from the geometric set. If you sum the angles, they will give you 180 degrees. That is to show that the sum of angles in a triangle equals 180 degrees. 360 degrees. You can illustrate it here. That this from here and to here. How many degrees? 180. How many degrees? 7. But only this one, how many degrees? 9. How many degrees? 9. Only this one, how many degrees? 9. So it becomes 180 degrees plus 90 plus 90. It's not a very time that you must be at time to that. It can be at fraction. You can sometimes be at fraction. So you take this angle, take this angle, take this angle, take this angle, add it to this one. No matter the way you divide it, which we have done with this. No matter the way you divide it, all of them meet up at the point to give you what? 360 degrees. That's what the fifth law is saying. It's fifth theorem. That some of angles in a triangle gives you 360 degrees. The interior angle of a triangle equal to sum of the interior opposite angles.
So
External rectangle equals to what is the sum of two interior opposite angles. Okay, these are things you have known. Put your own at 35 degrees. Set yours at 0, 10, 20, 30, 35. So that here is 35 degrees up to here. Towards W. Avoid the problem. Just remove the other ruler. You want to prove that this angle is equal to this one plus this. That this angle is equal to this plus this. The sum of angle, the exterior angle of a triangle is equal to sum of two interior opposite angles. Once you produce this line, this angle becomes exterior angle to this triangle. And you cannot consider this angle again because they have a relationship, angle on a set line. Is it not? It has a relationship with this. The other two remain in this and this. There are three angles in a triangle. This one now, you produce this line, then draw this as exterior to this triangle. This angle now is angle on a set line with this exterior angle. So they have relationship. What other relationship remain is this and this. They are the two interior opposite angles. So you want to show that this angle is equal plus this will give you this. And it's simple. So this one is 90. This one is 90. Do you agree? And what reason? Two parallel lines with transversal. So what is the relationship? Forget about that being right angle triangle. Suppose it's not right angle triangle, the law can still hold. So what is the reason for this angle to be equal to this angle? Very good. Corresponding angles. This is equal to this. Corresponding angles. This angle is equal to this one. What reason? Alternate angles. This and this are equal. Alternate angles. This and this are equal. Corresponding angles. This plus this. What? 125. This plus this. 125. So the theorem is verified that exterior angle of a triangle is equal to sum of two interior opposite angles. Someone asked me, what's the essence of all this? I said, when you were cramming it, without this thing, you cram it, you apply them. This time now, you practice it. After practicing it, when you meet a solution, nobody will tell you, remember this when they ask you a question. They can ask you to find this angle. For instance, you now start looking for relationship. They can ask you to find this angle, triangle. Can give you this. They will not give you any other one. They can give you this. Ask you to find this. Relationship. You just use this kind of relationship, which we are doing, to apply when you go back and pick your textbook. If you understand the topic very well, you can now apply. Because I can see that when I was talking of exterior angle, some of you were looking as if you cannot authoritatively say what is exterior angle. If this is a triangle, if you produce this line, what is this one? Exterior angle. If you produce this one and produce this is exterior angle. Huh? If you produce this one, it will become exterior angle. And at any time in a polygon, the sum of exterior angles of a polygon, how many degrees? 360 degrees. But the sum of interior angles of a polygon, interior angles of a polygon, and this say of a polygon, it depends on the polygon. Huh? Yes. If it's a triangle, 180. If it is a quadrilateral, If it's a pentagon, hexagon, 720. Then so on and so forth. Until to how many to what extent can you call the polygons? To what extent can you mention? 12. Do you think 12 is the last one? Do you think 16 is the last one? There are very many of them. When my book comes out, you will see it. It continued until 70 something, 1 million size. And continued until any type of, any size, any number of size. You call it the name. So, you see, so when this one is produced, this one becomes the zero angle. Is it not? Assuming you produce this, you don't want to go this way. If this one you produced, then this one becomes the zero angle. So it depends on once you produce a line in a triangle, at anywhere you produce it. If you produce this one and produce this one becomes your E. At any time you produce a line, this one becomes, both of them will be angled on a straight line. If you are giving this and you want to find, if I can be giving this, they want you to find this.